Hi guys, it's me again, Jamika Antonette Reyes, a BSCE 2 Block B student, and today I am going to share to you my answers in data analysis blog assignment. So we are assigned to have or to create a problem in z-test, hypothesis testing, linear regression, and correlation, and we are going to solve it. So let's start. So first, we are going to have a problem and solve it in hypothesis testing using the z-test. So this is my problem. So the population of all verbal GRE scores are known to have a standard deviation of 8.5. The UW Psychology Department hopes to receive applicants with a verbal GRE scores over 210. And then this year, the mean verbal GRE scores for the 42 applicants was 212.79. So using the value of alpha, which is 0.05, is this a new mean significantly greater than desired mean of 210? So now we are going to solve it. So this is the solutions in the problem. So in this problem, the mean under the null hypothesis, which is mu hypothesis, equals 210, and then the population standard deviation is 8.5, and then the observed mean is 212.79. So these are the given data in the problem. So therefore, the standard error of the mean using the formula standard deviation x bar equals standard deviation x over the square root of n. So 8.5, our standard deviation, and then our number of applicants, which is the square root of 42, and then the answer will be 1.31. So that is our standard error of the mean. And then to find the probability of finding a mean above 212.79, we convert our observed mean x bar to a z-score. So using the formula z-score, x bar minus mu hypothesis over the standard deviation x bar. So that will be 212.79 minus 210 over 1.31, the standard error of the mean. So that will be 2.13. So that is our answer. And then, so since this is a one-tailed test, because we are only rejecting HO if our observed mean is significantly larger than 210. So to make our decisions, we need to find the critical value of Z, which is the Z for which the area um, two, above is 0.05, I mean. And then looking at our Z table here for our alpha, which is 0.05, locate or you can see that our critical value of Z is 1.64. It is in the shaded area, which is the color red. So that is our critical value of Z. And then this is our graph. We can see that our alpha here is in the shaded region of in the right side, the 0.05, and then we can see here in the line our 1.64, and then in the right side also in number 2 above, we can see the 2.13. So it is clear that our observed value of z is 2.13, which is greater than the critical value of 1.64. So we therefore reject the HO. And then and then equi- equivalently, we can calculate the p-value for our observed mean and compare it to our alpha. For this one-tailed test, the p-value is the area under the normal distribution above our observed value of z. So, from our z table again, we can see here, or we can locate that our p-value is 0.01. So because we know that our z is 2.13, right? So our p-value area beyond the z is 0.0166. So that is our p-value. And then looking at our graph here, um we can see our 2.13 and the alpha or the area of p value, which is the 0.0166 in the shaded region. So our p value is less than the alpha, which is the 0.05. So if the null hypothesis is true, then the probability of obtaining our observed mean or greater is less than 0.05. So we therefore reject HO and state that the verbal GRE scores of applicants M equals 212.79 is significantly greater than 210, which is our Z is 2.13, and having our alpha, which is P equals 0.0166. So that is our answer in our hypothesis testing using the test problem. Next, we are going to proceed to line regression problem and solution. So this is the problem of the line regression. So consider the following set of points, which is -2 and -1, and then 1, 1, and then 3, 2. So A, find the least square regression line for the given data points, and then B, plot the given points and the regression line in the same rectangular system of axes. So first we are going to organize the data in the table. So you can see here in the table our data in x -2, 1, 3, and the summation of that is 2. And then in y we have -1, and then 1 and 2, and the summation of y is 2. And then in xy we are going to multiply the x and y. So -2 times -1, that will be 2. 1 times 1 is 1, 3 times 2 is 6, and then the summation of xy is 9. And then in x squared, we have the square root of the x, which is square root of -2 is 4, square root of 1 is 1, and then square root of 3 is 9. And then the summation of x squared is 14. And then we can now use the formula to calculate A and B as follows. So using the formula, N E, the summation of xy minus the summation of x and summation of y, over or divide n, the summation of x squared, minus the summation of x times 2. And then that will be 3 times 9 minus 2 times 2 over 3 times 14 minus 2 squared. And the answer will be 23 divide, I mean 23 over 38. And then to calculate b, we are going to use the formula 1 over n times the summation of y minus a, that the answer in a, times the summation in x. And then that will be 1 over 3 times 2 minus 23 over 38, the answer in a, times, and then the answer will be 5 over 9. So we are now going to answer the B. So we now graph the regression line given by A minus AX plus B and then the given point. So we are given, so in the problem we are giving points 1, 1, 3, 2, negative 2, 1. So this is the graph of the problem. So that is the solution in the problem in line regression. Next, we are going to proceed to correlation problem and solutions. So this is my problem. Janice and Paul had a study on feelings of stress. So Janice and Paul had a study on feelings of stress and life satisfactions. Participants completed a measure on how stressed they were feeling on a scale 1 to 30, and a measure of how satisfied they felt with their lives with a measured on 1 to 10 scale. And then the table below indicates the participant score. Using this data, answer the following questions. So we can see here in the data that we have 10 participants, and then the stress score, which is our X, and that will be 11, 25, 19, 7, 23, 6, 11, 22, 25, and 10. And then the summation of that is 159 or 15.9, and the standard deviation is 7.23. And in life satisfaction of the participants, which is the Y, and that will be 7,149,288,336, and the submission of that is 51, and then the mean is 5.1, and our standard deviation is 2.70. So the question is calculate the the question is calculate the correlation between stress and life satisfaction. So in the left side we can see here the scatter plot of the data. So that is what it looks like. And in the right side, that is the formula that we are going to use. So this is the the summary table of the solution. So we have our x, our y, the summation, the mean, and the standard deviation. And then we can see here the x minus x. So we can see here in our table the summary of the solution. So we have our x, our y, our summation, our mean, and our standard deviation. And then we are going to use the formula and then fill in the informations or the data. So using the covariance to solve the correlation, r equals negative 186, the summation of the x minus mx, and then the y minus my. So that will be negative 186.90 over 10, the n, the number of participants, times the 7.23, the standard deviation of x, and then the 2.70, the standard deviation of y. And the answer will be negative 0.957. And then using the z-score formula, so this is the formula that we used. So correlation r equals negative 9.57 over 10, the number of participants. So the answer will be the same, which is negative 0.957. So we are going to round the answer into two decimal points. So the answer or the correlation will be 0.96. So that will be all. Thank you for listening and thank you for watching. Bye.